Okay, so today we're looking at trigonometric equations. Our learning intention is to gain the knowledge in how to calculate the degrees or the radians that make a trigonometric equation true. So, i.e. the solutions to that trigonometric equation. We'll be successful if we can understand the repetitive nature of a trigonometric function and that they're waves and there's more than one solution. Understand the idea of all stations are central, or what functions are positive in which quadrant. So what functions are positive in which quadrants? And understand the period of a trigonometric function. Okay. So some examples. So a trigonometric equation is asking us to state the solutions in either degrees or radians that make the trigonometric equation true. So here we've got sine theta equals 0.6. So that's what is that? What that is saying is, which degree does sine theta equals 0.6? Now it goes from 1 to -1. So 0.6 is somewhere like here. So as you can see on our graph, there's going to be two solutions. So what we do first is, well, we can do inverse sine. So make sure we're in degrees, because it says from 0 degrees to 360 degrees. So we're in degree mode. So inverse of 0.6 sine. So it gives us, we went to the nearest degree, so it gives us to approximately 37 degrees. Okay. But knowing our quadrants, stations to central, in the first quadrant, all trig functions are positive. So we have that, we have the 37 degrees. But we need to find the other possible solution. In this case, it's going to be in the second quadrant, because sine is positive in this quadrant. Okay, so this quadrant is technically 180 degrees minus theta. Okay, so if theta was 37, the other solution is 180 minus 37 degrees, which is 143 degrees. So sine theta equals 0.6 when theta is 37 degrees or 143 degrees. Okay. Next example, we want to find when cos theta equals 0.45. So somewhere here, and once again we see it happens twice. So what we will do, we find out what theta is. So shift cos 0.45. So it's going to be to the nearest degree, approximately 63 degrees. Okay. Now, using that's my 63 all stations to central in the fourth quadrant. And the fourth quadrant is 360 minus theta. So this would be, the other theta would be 360 minus 63 degrees. Gives me 297 degrees. So theta is 63 degrees or 297 degrees. Okay, let's look at this example. So tan theta equals 0. Well, using our graph, we can see that here it happens 3 times. Okay, so theta equals inverse tan. And if I did that, I should get 0. Correct, right? But using our graph, we know that it also is 180 degrees and 360 degrees, because tan has a period of pi. Okay, there's the solutions. Often we're going to be asked to find the solutions using exact ratios. Okay, so if I want sine theta equals a third, so that's when the opposite is 1 and the hypotenuse, no, so that can't be right. Let's say root 2. Okay. So sine theta equals 1 over root 2, where the opposite is 1 and the hypotenuse is 2, well, that's 45 degrees. Once again, we know that sine is positive in the first and second quadrants, so we also have the 180 minus 45 degrees. So theta is 45 degrees or 135 degrees. Okay, if I want cos of a half, when I want the adjacent is 1 and the hypotenuse is 2, so I've got theta is worth 60 degrees. That's in the first quadrant, but cos is also positive in the fourth quadrant, which is 360 minus 60. So theta is worth 60 or 300 degrees. Okay. Tan theta equals root 3. So that actually can be written as tan theta equals root 3 over 1, where the opposite is root 3 and the adjacent is 1. So opposite is root 3 and adjacent 1, so this is tan 60. So theta is 60 degrees, but tan is positive in the first quadrant, or stations 2 and the third quadrant. Now in the third quadrant, that's actually 180 plus theta. So we get 60 plus 180, 240. So theta, so the solution to this is 60 degrees or 240 degrees. Okay, and that's using exact triangles. Now we could ask to go backwards. So this is assuming from the unit circle we are going in an anti-clockwise direction, that we are traveling this way. Yeah. So that is theta. This is 180 minus theta. This is 180 plus theta, and this is 360 minus theta, going this way. Now we want, because we know that these trig functions are waves and they continue and they're repetitive, we can now find the solutions going backwards. So what I'll do is I'll draw in the middle here. Now the all stations to central stay the same. Okay, but now we're going to go this way. Okay, so this would be, so this is 180, and then I'm going to add theta to cut them closer to 0. This would be negative theta. This would be negative 180 theta minus theta, so I'm getting further away from 0. And then this would be 360 theta, so 360 degrees plus theta. So we're coming closer because we're traveling away. So, okay, so when I want sine to be positive, so we know that theta technically was 45 degrees. Okay, but we're going to go backwards. So thinking of it, I'm just going to do a very rough sketch. Okay, so we want it to be up here somewhere. Yeah, so we know that's positive in the first quadrant, which is technically negative 360 plus theta. So negative 360 plus 45 gives us negative 315 degrees. Yeah, that's one solution. That's this one here. And we also have another one. It's going to be in this second quadrant, yeah, which is technically negative 180 minus theta. Minus 45, which is negative 225 degrees. So that was negative 180 minus theta, and this was negative 360 plus theta. Okay. Now let's do the next one. We've got cos of theta equals root 3 on 2. So when the adjacent is root 3 and the hypotenuse, this is 30 degrees. Okay. So drawing a real quick sketch. Right, we're going to have another two points, right? We're going to get the first one, which is negative 360 degrees plus 30 degrees. And we've got this one, which is negative theta as well. So we get negative 30 and negative 300 degrees. 330 degrees. Okay. Okay. Going backwards, we want tan of theta equals to negative 1. Sorry, tan theta equals to 1. So using our graph and going from 0 to negative 360, we have 2 points. Okay. Now, theta is 45 degrees. Okay, so we're going to get two solutions. We're going to get negative 360 plus 45. And we're also going to get this one over here, which is negative 180 plus 45. So the solutions is negative 135 and negative 315 degrees. Okay. Alternatively, we can be asked to find them in radian modes instead. Okay, so you need to make sure that you flip over the radian, so you do that by doing shift mode 4 for radians. Okay, so if I did shift sine of 0.6, I will have, let's do it to 3 decimal points, 0.64 3, right? That's in the first quadrant. And the next one, well, this is going to be pi minus theta. So I'm going to write and I get 2.498, 3 decimal places. Okay. So cos is positive in the first and fourth quadrant. So cos is 0.45. We get 1.104. And then we also get 2 pi minus that. You get 5.179. Okay. Tan theta equals 0. We remember that it was 0, 180, and 360. Well, that's going to be 0, pi, and 2 pi. Okay. We're just going to quickly convert. So we've done the solutions to these ones before. Okay. So I've got 45 degrees and 135 degrees. So remember, we just want it in radians. We can convert this into radians by timesing it by pi on 180. Yeah. So 45. This is 45 degrees into radians is pi on 4. And then 135 is 3 pi on 4. Okay. I'm just converting these solutions. So we had 60, which is going to be pi on 3, and we had 300, which is 5 pi on 3. And you can go back to the solutions that I've done before. So this is going to be 60 as well. So that's pi on 3, and 240 is 4 pi on 3. Now, that's using the exact triangles. Let's quickly draw some. Okay. 45 is pi on 4. Six degrees pi on 3, and 30 degrees is pi on 6. Okay, that's just converting our exact triangles from degrees into radians. Okay, we went backwards. This was going backwards from negative 360 to 0. Oh, sorry, negative 2 pi now to 0. So 225 over 180 gives me negative 5 pi on 4. And then we've got 315, which is negative 7 pi on 4. Negative 30 is negative pi on 6. And negative 330 is negative 11 pi on 6. And 1, so we've got negative 3 pi on 4, and negative 7 pi on 4. Okay, a few more examples. So we're going to solve for 0x to 2 pi, so we're going to work in radians. Here we've got sine, instead of being sine theta, we've got sine of 2 theta or sine of 2x. So what that means is if it was x, we would have the solution going from 0 to 2 pi. But we've got 2x. So we're going to multiply both sides by 2. So that stays 0, and this is going to go to 4 pi. Okay. So we want, remember, inverse sine of 1 over root 2 is pi on 4, or 45 degrees. Okay. It is positive in the first and second quadrants. So we've got 2x. So the first quadrant, we've got pi on 4. Yeah. The second quadrant, we've got pi minus pi on 4. But we're going around twice, right? So in the fifth quadrant, we've got 2 pi plus pi on 4. And in the sixth quadrant, we've got 3 pi minus pi on 4. So we still get pi on 4. We get 3 pi on 4. 9 pi on 4. And 11 pi on 4. Okay, so that's what 2x is. But what we now need to do is going to divide everything by 2. And that's the same as multiplying by a half. So you get pi on 8, you get 3 pi on 8, you get 9 pi on 8, and 11 pi on 8. And that's the solution. Okay. All right. So same thing, we've got cos of 2x now, but we've got negative 1 on root 2. So once again, we're going from, I'm going to multiply if it was 2 pi, so now it's 4 pi. Okay, and now it's negative. So we want when cos is negative. Cos is negative is in the second quadrant and in the third quadrant. So we know that theta x, or 2x, is 45 degrees, right? So when we want it in this angle, right? So that is going to be pi minus pi on 4. Then we've got pi plus pi on 4. So this is second quadrant, third quadrant. Now we're going back around, so that's 2 pi, but still need to go 4 pi. So we've got 3 pi minus pi on 4. So it's the sixth quadrant. And then we have the seventh quadrant, which is 3 pi plus pi on 4. So we get 3 pi on 4, 5 pi on 4, 11 pi on 4, and 13 pi on 4. Okay, multiplying by a half or dividing by 2, we get 3 pi on 8, 5 pi on 8, 11 pi on 8, and 13 pi on 8. Yep. So be careful when we have the period changing. Okay. Another example we could possibly have is something where we have like a quadratic or an equation. So I'm going to factor out sine theta. I'm going to actually convert this to 0, sorry. Alright, the reason why I wanted to convert it to 0 is so now I can apply the null factor. So what I've just done is factorized sine out the front. So we have this possible solution where sine theta equals 0. So that's going to be at 0, pi, and 2 pi. Yeah. And then we have this idea where sine theta plus 1 equals 0, which means that sine theta equals negative 1. Yeah. So in this situation, using our same graph, this point here, and that's going to be 270, 3 pi on 2. Yeah. And so now what we do is we write the solutions in order. So we go, solutions are 0, pi, 3 pi on 2, and 2 pi. Okay. There are some other examples. All right, good luck.